This is Harvard on the Map, presented by the Harvard Graduate School of Design, covering innovative ideas and thought leaders in digital cartography, Earth observation, and all things geospatial, with your host, Jennifer Horowitz.
Welcome to Harvard on the Map. I'm here with Nick Rabinowitz, and thanks for coming on the program, Nick.
Sure, my pleasure. Happy to be here.
Nick started at Uber and then is now at Unfolded, which is also work I'm very, very excited to hear about. But I thought I'd start by kind of getting a sense of your background and how you came to Uber and to their engineering team. And yeah.
Sure. I have a pretty circuitous background. I started many years ago, too many years ago, as an English major at Amherst College. And then did a bunch of different jobs after that, largely focused on the web. So when I was at Amherst, it was the very early days of the web, and I taught myself HTML, and that was enough to get a job doing web programming. And so for many years, I was a web programmer in nonprofits and some NGOs. And I eventually went back to get my master's degree at the Berkeley School of Information, and did a lot of work there on information visualization, information management, and GIS, and got a bit more sort of programming chops and actual expertise instead of stuff I had just taught myself. So I've always been interested in visualization. I've always been interested in mapping, but that was where I first started to get some actual experience in it. And after that, I did consulting for a while, still with nonprofits, some with the UN, working on disaster response. And, increasingly felt like what I really needed was more technical skill to be able to make technology really work for the organizations I was consulting for. Sure. There's a huge amount of really interesting mapping you can do in a context like UN disaster response, and it frequently wasn't being done because people didn't have the technical skills to pursue it. And so I started working with a startup that was doing essentially sort of business analytics, but with a heavy visualization focus. This was called Clear Story Data. And I worked there for 3 years. And as startups, often do, it wasn't doing as well as we had hoped in 3 years. And it started to be time to look for something else. And the Uber job came along and was also very visualization focused, very mapping focused. One of the things that really fascinated me about Uber was the amount of geographic data they had, and the potential for what they could do with it, and also the fact that they had a big data infrastructure that you could rely on when dealing with really large amounts of geographic data. So I started working for Uber, and I spent about 5 years there, working almost entirely on internal applications. And I got to do a lot of really interesting stuff, especially in the mapping space. One of the things I worked on there, which I think maybe why you're interested in my work at all, is to start working with H3, which is this discrete global grid system developed at Uber that basically divides the whole world up into hexagons and allows you to do a lot of really interesting analytics and algorithms over the world using that grid. I got to work initially on the sort of front end piece. My background is really my technical skills center around front end development. So building, client side applications, but I also got into the core library as well and started building out algorithms in C and really enjoyed that. Mm-hmm. And then when I started thinking that it was time to leave Uber, I looked around and a lot of my favorite people from Uber had joined together to start this company Unfolded, which is, basically using some of the really amazing open source software that we developed at Uber and putting it together into an application that can, really do a lot of interesting work in the GIS space, bring a lot of, deep analytics and things that we had to do custom at Uber in a very, sort of time intensive way and requiring a lot of custom systems into a space where everyone could use them. And we can, everyone can can use the interface that they're familiar with if they've ever used Kepler GL, but then rely on a deep set of backend analytical functions and capabilities, largely supported by H3, by our hexagon grid.
Wow, that's fascinating.
And I've now been at Unfolded for about a month, so I'm still pretty new there.
Sure.
Pretty exciting.
Wow, that is incredibly exciting. I'd heard about Unfolded just as I explore the entire arena. I've loved Kepler GL.gl, and I have used it, and I think that the visualizations just on an artistic aesthetic level are gorgeous, but I'm getting ahead of myself. I'd love to, I think that a lot of our listeners may be very surprised to even know that Uber has its own, engineering and analytics platform if you're not familiar with the arena as much. And so I thought I would first touch on H3. So I wonder, if you could go into that and explain, for some of our listeners who may not be as technologically savvy, how H3 works. That would be wonderful.
Sure. This is the place where I wish I had some visual aids, but I'll do my best. So H3, as I said, it's a discrete global grid system, which basically means that it divides the entire world up into discrete cells, areas of the world. Any point in the world is going to end up in one cell. And it covers the world with these cells that are about equal area, about equal shape. They're almost all hexagons. I won't get into the details, but you're basically required to have some pentagons. You can't cover a globe with just hexagons, unfortunately. But almost all of the world is covered with hexagons. And it's a system, so rather than being one grid, you have many grids at different resolutions. So you start off with a resolution 0, which is roughly continent sized. I think there may be 122 base cells at resolution 0. And it goes all the way down to resolution 15, which is about a square meter. So you end up with this way to uniquely identify areas and portions of the Earth in a way where you can really compare them. They're all, as I said, they're all equal area, they're all approximately equal shape. And so you get a really good ability to have apples to apples comparisons in different ways. And you can run algorithms over them. So, I've done enough mapping to know that the real world just gets really complicated really fast. It's really, it's just filled with all these ridiculous edge cases. And no matter what you're trying to look at, if you look at counties or zip codes or any other kind of admin boundary, you end up with all these cases that you have to consider separately. And it just gets very messy. Nothing in the real world really fits into those admin boundaries. What a grid like H3 does is it gives you this kind of neat mathematical space that you can map the world to, and then you can work with it in a mathematical way that's much simpler and more straightforward than it is to work with the actual messy reality that you frequently deal with in less abstracted views of the world. The other thing I really like about H3 is that if you use it in lots of systems, it gives you this common unit of analysis, the hexagon cell, that you can bring lots of data into. So you can take, raster data, you can take images, you can take polygon data, you can take admin boundaries, you can take point data, and you can convert all that to a hexagon representation. And then you can mash it together in various different ways. So you can do things to unify your data that are much more difficult, I think, using non-grid based approaches. Otherwise you have to choose which of your data representations is going to be the one true representation. Are you mapping everything to counties, or are you mapping everything to some kind of raster cell? H3 gives you a sort of solid default for that you can use for many different data sets.
It's fascinating. I have a lot of technical questions in terms of why you chose hexagons or the geographic grid system, but I think our listeners would probably be most interested in how this H3 system gets applied in real life context.
Sure.
Yeah.
Sure. So, one very common use for H3, there's a lot of different things. It's a very general purpose kind of system. One very common use is simply indexing. if you have a lot of points, and in a context like Uber's, where H3 was developed, obviously those points might represent the position of a driver, the position of a passenger, the position of a restaurant, and the position of a person ordering food. And if you have all these points, you can, if you're trying to deal with them in latitude, longitude, you have this problem of trying to figure out things at very different levels of specificity, perhaps very different places around a city. If you index them all to H3 cells, then you have them in this relatively uniform space that makes it much easier to run different kinds of algorithms, or even just to do simple things like a radius lookup. If you're satisfied with a radius lookup that's approximate, you can easily take the hexagon a point is in, or the ring of hexagons that a point is in, and just do a very fast lookup for other things in that radius. It's much, much faster and more efficient than doing a traditional radius lookup, where you're actually like basically looking over every point and trying to figure out which ones are close enough. The first use of H3 in Uber was around surge. And so the idea with surge was you want to figure out where there are lots of people requesting rides and sort of compare that to where there are lots of cars available for them, and then adjust prices accordingly. And part of the problem is that when you say where are the people requesting rides, well, if you're just using point data, which is what you have as your input, it's hard to say sort of how to represent that in a way where you can tell whether they need more prices or not. Are these people close together? Are they not? You have a sort of n squared problem, looking at every single point and trying to figure out how these things should go together. The way that we used H3 to solve this problem, and this was the first problem I think that Uber tried to solve with H3, was to put them into the hexagon grid, aggregate per hexagon. So you could say there are 20 people in this hexagon, and then kind of spread that out a little bit, because it's not just whether you're in the hexagon and whether there are cars in your hexagon, it's whether there are cars nearby. And so we basically took these aggregated hexagon counts, and we would spread them out, kind of smooth the surface, and you end up with this smooth surface of demand that you can use to set prices. And so effectively becomes this smooth pricing surface that you can use to adjust prices in your app.
Mm-hmm.
A lot of users don't like surge, and there are lots of reasons for that. And I have no I have no agenda on whether or not surge is a good idea from a product standpoint. But it was a very interesting technical challenge, and H3 is a really good solution for it. As Uber adopted H3 more and more, we ended up with all these other use cases. So we use it generally as an indexing system, but in a sort of lookup system to try to find things quickly. We might use it as a gating system. So if you want to figure out whether someone is in an area, the area of a restaurant, for example, you could define that area as a set of H3 cells and then do a very fast lookup to determine whether you were in the service area. And we ended up having a lot of different uses involving hex clusters. So if you're not happy with the admin boundaries that you're given as a way of defining your world, because admin boundaries tend to be very arbitrary. They're defined by requirements that might not be yours, right? They're defined by political requirements or postal requirements if you want to use zip codes or other kinds of external factors that might not have to do with your actual use case. Then you can create your own admin boundaries by doing various clustering algorithms over the H3 grid. You end up with these clusters of hexagons that together form a particular area in the city, and then you can do things with those entities as though they were admin boundaries. And you might have many different sets of admin boundaries that work in that way over a city for different use cases, whether you're trying to make the Uber service more efficient, or whether you're trying to turn around and use it for Uber Eats and make restaurant delivery more efficient. You can define different kinds of clusters for those different use cases and do different kinds of analyses on them.
Wow, that is incredibly fascinating. I think I may be similar to someone who's listening. I didn't even understand how extensive Uber's engineering team is, and then as I really started to get into geographic data and working with spatial data, I mean, I just find this fascinating. I could probably talk your ear off for an hour with questions, but I know that you're a busy guy and I don't want to take too much of your time. But I would love to hear about your work at Unfolded as well, and how that. I mean, you talked a little bit about how that came to be, but what you're doing there and some of the exciting things that they're working on.
Sure. So as I mentioned, I've only been at Unfolded for about a month, so my
Sure.
story there is going to be a lot lighter. The things that attracted me to Unfolded as a company, one is the people. I had worked with many of the people before. I knew them to be, super smart and very good to work with. And the other is the technologies, mostly developed by the same folks. So DECGL, Kepler-GL, and H3 are the kind of core technologies, core open source technologies that we're bringing together at Unfolded to create the Unfolded Studio application.
I see.
And they all kind of bring different strengths to the table. DECGL is this really powerhouse WebGL library to do different kinds of visualizations over maps, and to do them in the browser in a very high performance way, which allows you to do all sorts of things that would be very hard to do otherwise. Things that previously had been the domain of desktop applications or other kinds of applications where you really needed a lot of basically computational power. Now we can push that to the GPU and do these things in the browser in a way that is much more accessible to just regular users.
Sure.
Kepler-GL, as I think you mentioned, it's increasingly used in the GIS community, and it leverages DECGL to provide this pretty easily to use in the browser experience that is starting to rival other kinds of more serious and established GIS tools. Yeah. And I think also maybe makes that set of functions a lot more accessible to people who might not be GIS experts. Not everyone has ArcGIS on their machine. Not everyone could use it if they did, but Kepler allows a wide range of people who might be data scientists without a GIS background. They might be journalists, without a strong engineering background, and they can use this tool to create a beautiful map, but also a map that really answers a question or, solves a problem that you're trying to solve. I love beautiful maps, but I tend to be very focused, and this is true for data visualization as well. I really want to solve somebody's problem. I want to answer somebody's question. And I think that what we have the opportunity to do by bringing H3 into that mix is to bring all these things together so that you can both create beautiful maps, but you can also do these kind of high-powered analytics that maybe would be difficult to do in other contexts. The most kind of obvious example, and probably the sort of foundational piece here, is data unification. So as I said before, if you want to combine a point data set and a data set based on admin boundaries, states or counties or what have you, let alone a raster data set that might be coming in, as tiles of elevation data or something else. If you want to combine all these together in a traditional setting, it takes a great deal of actual skill, knowledge, and in many cases, specific applications that you need to have installed and know how to use. We would like to make that a very simple and easy process. And I think that's, to me, the most exciting feature of Unfolded, is that you can take these disparate data sets and put them together using H3, get them into a space where you can work with them all together. And instead of just sort of seeing them overlaid on the map, which I think is probably the most common approach to data unification in the mapping world, is like, I'm going to put my heat map and then I'm going to put my point data on top of it. I'm going to put this other thing on top of that. You can actually start to do something more like real analysis. You can say, in this cell, we've got this many points and we've got this value coming in from the polygon that encloses it. And we've got this value coming in from the raster data. And we can start to answer real questions that combine those things, that look for correlations, or, for example, the easiest example here is I can take almost any data set and then I want to normalize it by population. Well, if I have population as an H3 layer and I have my data set as an H3 layer, then that's a simple calculation that I can do for every cell. And now I have a population normalized data set, which, traditionally is something I think relatively difficult to do.
Fascinating. I know I keep saying it, but it's just, this has been the thing I've been most looking forward to my whole week. I've loved exploring Kepler. I've loved exploring H3. I think your work is fascinating. I'm very jealous of what you do. My final question, which I end all of my my radio shows with, is I ask my interviewees to describe a time where they were lost, whether that's geographically or in their career, and how they found their way back again.
So you mentioned before this interview that you might ask this question, and I've been thinking about it a lot.
Yeah.
And I realized that there's so many times I've been lost in my life. I came up with so many different stories because there have been so many points either in my career or actually in real life where I felt somewhat lost. And it was a little bit difficult to choose what would make the most sense. I think from a career standpoint, the point just before grad school, I was working in Atlanta. I had moved there with my wife for my wife's job, and I was working for a nonprofit and doing interesting work, but in a sort of sphere that I wasn't as interested in. So I was basically writing copy for their website, which effectively meant writing a lot of fundraising emails and a lot of sort of fundraising copy. And while I was working for Care USA, it's a great organization, but I didn't really want to be writing fundraising copy forever. And I was in my mid-20s and just feeling like I didn't know what to do next. I liked working with these technologies, but I hadn't been able to figure out how to actually get a foothold in a way that I could have a job doing technical work or doing the work that I was most interested in. And then as far as I can remember it, my wife kind of looked up one day and was like, hey, you should go to one of these information schools. And I had never heard of an information school. And I think she was either reading an article about it or had heard about it from a friend. And I started looking into them. And, information schools are such an interesting set of institutions. They're all relatively different. They cover similar topics, but, whichever school you go to, it's quite distinct. And they tend to be very interdisciplinary. You bring in all these different aspects. And, I suddenly looked at that and said, that's really where I should be. That's what I want to do. And I looked at a couple and let's just say I was looking in relatively early spring. And if you go to different parts of the country in early spring and then you go to Berkeley, you end up at Berkeley. It's a beautiful place to be. It just looked like a picture perfect campus, and the school is just really, really interesting. Lots of focus on, social issues of information law and policy, coupled with, technical focus and, HCI and user experience, just a lot of really fascinating areas to bring together. And so I think that was sort of how I found my way at that period in my life. And I think that I've never regretted that move from this sort of directionless place where I was at that point in my career to a really just interesting and rich environment where I learned so much. Wow.
I very much personally understand that because I was not, I'll admit, a CS undergrad, and my graduate work was sort of where I began my CS journey, and I'm still 2 of 3 years in, but it's actually great to know that you didn't, it's not as though there are these people who I was in some CS classes with at Harvard where there were these people we called fetuses, who are people who are born, they type hello world right out of the womb, and sometimes it feels daunting, but I really appreciate that you kind of came to CS and to information technology at a later point. I really very much understand that. Well, I appreciate your coming onto the show, and I really appreciate your time.
Sure, it's been great to be here. Thanks so much for inviting me.